Makers, welcome to my shop. I'm the Calculated Carpenter, and I have to admit to you I have a bit of a problem, and that's my wood storage, or lack thereof. I've been making do with this for a while. I've got dimensional lumber, hardwood lumber, all mixed together. I have the clamp rack of death I have to contend with anytime I'm searching for lumber, and it's time I solve it. So in this video, I'll show you how I've taken this and turned it into this, as well as why I've gone DIY versus purchasing something off the shelf. I will be releasing plans for this, but don't worry when you see me use my CNC. If you do not have a CNC, I have two ways for you to make this with traditional woodworking tools as well. So let's start making and get this cleaned up. The first step was sourcing some plywood and breaking it down, and while I do that, I want to walk you through why I'm going with a DIY solution. The first rack I looked at was this style, which while it would be suitable, it would be very expensive because of how many I would have to purchase, as well as I was concerned about the amount of weight-bearing capacity they would have. The next solution I looked into was a vertical rack storage solution, something like this. However, in my work area, my ceiling height is limited, so this too was out of the question. My final solution I looked into was the more industrial style racking like this, and while it's very nice racking, it's more costly than I can dedicate to this at this moment, and it would take up a lot of space. So we've cut down the plywood, and I've laid out all the material I'm going to be using here behind me, and before I start milling it on the CNC, I want to give you a few tips for sourcing your plywood. So whenever possible, I source my plywood from an industrial plywood supplier versus going to the big box store. And the key reasons for that and kind of what I've noticed between the two different products is that when you go to a big box store, the plywood's expensive. I'm paying anywhere from $60 to $80 a sheet for the limited selection of quote unquote cabinet grade plywood that my big box store sells. And when I go to an industrial supplier, I'm getting a product that has more plies to it. There's a greater selection, like this product here is a 3/4 inch birch plywood that's pre-finished on both sides. It's a grade C2 of material, which means I will be faced with some imperfections in the wood. Like you see here, this knot on the face, but we're doing shop fixtures, so that's just fine with me. This was $45 a sheet at the industrial supplier. Now they were having a sale, it's normally $55 a sheet, and that's a great price. But no, when you have that bigger selection, you can get things like the pre-finished woods, and if you go down in grade of material, like this being a C2, you save money that way as well. So look for an industrial supplier in your area if you have one, because I think you'll save some money on sourcing your plywood. Next up, I have kiln-dried and heat-treated lumber behind me, which is what's going to be mounting on the wall for our brackets to go onto. I'm putting this on a CMU block wall, and I should be using pressure-treated lumber, I know that. The reason I'm not is because I would like to paint this right away and not wait 6 months to paint it or have to try and paint it in place. My CMU block wall is treated with dry lock and then it's painted on top of that. So I'm going to have a painted surface of masonry touching a painted surface of wood. It's not a permanent structural element of my shop, so I'm not worried about it. So I know it's wrong. Don't torch me too bad in the comments. When you're doing your install, if you're going to masonry, you can choose to use whatever makes you most comfortable. And we are ready to start milling. I'm gonna throw this on the CNC. I'll show you my setup and kind of how I've optimized this while I'm setting it up on the CNC to use the maximum amount of a sheet of plywood so there's very little waste. Let's start milling. Removing this first sheet of plywood, you can see how closely the brackets will nest together in the cut file, and this is optimized to ensure we're able to get the most amount of brackets possible out of one sheet of plywood, making the system scalable. So if you purchase one sheet of plywood or you purchase 4 sheets of plywood, you'll know exactly how big of a setup you can make and tailor that to your needs. For work holding on this project, I'll be utilizing the T-tracks and hold down clamps on my machine bed. I've also opted to use tabs when I cut this file so that all of my brackets will stay integral to one large sheet until I go back later and cut the tabs. This allows me to simply run a quick flush trim pass on a router, and my brackets do not need individually secured or held down with double-sided tape during the cut process. My tooling strategy for this project will be to first utilize a 1/4 inch down cut end mill to break that top surface of the plywood with no splintering or tear out. Then I'll be switching over to a 1/4 inch compression bit, which will ensure that when the bit cuts through that final layer of plywood, I will also have no splintering or tear out. I'll share the bits I'm using in the description below. I have no affiliate link here, so I'm just being transparent, sharing the bits that I really like using. Keeping near the machine while it's running, I took this time to work on some emails and some of the upcoming steps for this project. I wanted to stay near my machine in case something bad happened, and, well, unfortunately, I unknowingly was about to start experiencing some problems that would continue for the rest of this project. Warning, this will be loud, but I'm going to share with you the sound I heard, which started it all. When I arrived to the machine, all I could do was panic stop the machine with the emergency shutoff because the bit was now fully embedded into the aluminum tracking below the work surface. My initial thoughts were that my bit pulled out of the collet due to vibration or chatter in the cut and pulled itself down into the work surface. I will, however, soon find out after a couple repeated failures that was not my issue, but I don't know that at this time. To reset my machine and hopefully salvage this cut, I first disassembled the router to remove the router from the hold down and then remove the bit so I can reset the Z-axis. I should have realized at this point, because the Z-axis was fully depressed in the material, that there was actually a bigger issue here at hand, but I'm none the wiser at this point and continue with the reset process. Since my machine is not a closed-loop stepper system, my only hope here is to guess and check the best I can and restart this job at the exact same point as before, and since this is just for the shop, that'll be alright, but if this was a client job, this set of material is most likely wasted. With the CNC back to work, it's time to prep the miter station and mark out some material so I can begin cutting down my verticals to length and start putting the paint on them. Well, I guess this really isn't a miter station, but it's something I need to build out in the future. My background in on-site carpentry, I'm used to just working off of a miter stand, and I've been making do, but it's definitely not ideal. I've sped up the painting a lot because I think watching me paint would be about as much fun as watching paint dry. However, what I'm doing here is just putting on a couple coats of exterior paint that will protect the wood from soaking up moisture from the masonry. You see me putting white paint on the back. That's just because I had more white paint on hand than I did black paint. I like to try and use up what I have in the shop when it's a shop project. While painting, I faced repeat failures with my machine, and this is when I noticed that the failure method was not the bit pulling out of the collet, but rather the Z-axis plunging all the way into the table. So I reached out to Carbide 3D support, and they were excellent with a quick reply to let me know they had some faulty cables in years past, and were quick to send me replacement cables for my 3-year-old machine. I actually did not have to even pay anything for these cables, which is even more impressive to me, so great job to them. After battling through with the machine to complete enough brackets to build out my system, it's now time to go through and cut all of the tabs so I can prepare to flush trim these on a router. For this, I'm just using my oscillating tool, going through and cutting them out. Now, because I did have a few machine failures, you will see at times here I have to use my jigsaw because the bit may have only cut about an 1/8 inch or so deep through the brackets. This gives me a chance to show you how you can make this without a CNC, because if you have a way to make a template, you would be able to simply use a templating bit on your router like I'll be using for flush trimming and cut out all the brackets this way. Included in the file pack, I'm going to have an SVG of a single bracket, so you could use a laser if you have that to cut out thinner material that you could then use a standard router table and template off of. Or, if all you have is a standard router table, I will also have a fully dimensioned sketch so that you can very carefully by hand make one bracket to a precision tolerance, and then you can template that single bracket on your router table. Stepping up to my router table, you're going to see me use a flush trim bit with a top bearing, and the first cut I'm doing here is one that the CNC router performed about an 1/8 inch depth of cut on, and then the issue happened where the bit plunged itself all the way down into my metal substrate on the work table. Not ideal. As this continued to happen to me, I then would remove the stock from the CNC bed, use my jigsaw to cut out the bracket close to the 1/8 inch depth of cut guide that the CNC router gave me. And now what I'm showing you is essentially the process you'd be doing if you would go the template route and not use a CNC router. So I'm just taking care to go all the way around my bracket, ensuring my bearing can ride on that 1/8 inch depth of cut profile, which in your case would be the template. And after I get a single pass all the way around, I go a little bit faster just to clean up the edges and make sure everything is nice, flush, crisp, and clean. Having worked through my brackets that were troublesome in the beginning, I could now work my way through the brackets that cut out properly on the CNC, and these were only left with about 6 tabs around the perimeter, and the tabs were approximately an 1/8 inch tall by an 1/8 inch wide. This is ideal as the material on the top surface and the bottom surface is splinter free. Some of my brackets that were cut later after some of my bits were ruined were cut with bits that were non-optimal, and I did have a little bit of tear out on the bottom side due to the machine strategy I had to use. Since this was just something for my shop, I was okay with pressing forward, and then I would just touch up those brackets with a piece of sandpaper as needed. I'll be honest though, I'm a bit of a perfectionist, so it still bothers me, but let's move on. Okay, so all the brackets are now cut on the CNC except for the final 6 brackets, and that's because I'm waiting to cut those until I make the repairs to my CNC, and then I can use that final cut to validate the repairs indeed fix the problem, because just about every cut I was noticing the issue happening at the end of the cut file. And it's right around a 20-minute job. Shorter jobs, it doesn't happen. So whatever's going on with the machine seems to time out, lose its connectivity near the end of a job, and just plunge the Z-axis right down into the table, ruining a bit. Now, the downside to that is I went through my upcut and compression bits, and I had to use different bit strategies for some of the final cuts, and I now have some splintering on the bottom side of some of my brackets. When I flush trimmed on the router, I just kind of hit that with some sandpaper on the backside, and because this is just holding my lumber, I thought that's okay, and I was okay just pressing forward through the job. Luckily, it wasn't a client project or something of that nature that I would have to have been stuck just waiting on packages, because that can be a very stressful situation. So they're ready to go. I also have the verticals painted and fully ready to install. So what I'm going to do first here is I'm going to install my verticals with Tapcons on the CMU masonry, and then I'll set up a laser level to start mounting a few brackets on each level. And then I'll use my physical level to sit across the mounted brackets and then mount the rest up to my level so everything's perfectly in plane. This is going to take a little bit of time, so I better stop talking and start doing, and let's get this done. You may be wondering what the wire is that's been hanging from my ceiling and is now kind of wrapped up above my head there, and well, it's one of those projects where I had to replace the power supply to my under cabinet lights and am yet to fully complete that project. I think the problem when you're a maker is you can kind of get a lot of things in the air at one time, and I need to finish some of these tasks. For the masonry installation here, instead of using my large SDS hammer drill, I'm actually using a standard drill driver with a masonry bit and a hammer setting, and this is just a little bit more gentle on the block, so I'm less likely to blow it out. And instead of using my impact to fasten the Tapcons, I'm actually using a standard drill driver on just a driver setting, so that again I don't overdrive those fasteners and strip out the block. I also found it helpful that I would pre-drill the wooden risers so the Tapcon was not trying to thread itself into the wood and thread itself into the block at the same time, kind of working against each other there. In the file pack, I include 2 blueprints. One is for what I'm calling what I'm doing here, the heavy duty system, and the other is for what I'll call the standard duty system, and that just dictates the spacing of your uprights. I've spaced my uprights here 16.5 inches apart from one another, and they'll each have 2 brackets on. Depending what you're doing and how much weight you're going to put on, you could increase the spacing and go down to 1 bracket instead of 2. But because I use MDF pretty often, even though I really don't like MDF, it's pretty heavy, and I want to just be sure that I can really set and forget anything on here and not have to come back and worry about it in the future. The small piece of wood there at the bottom is just a 2x4 I'm using to space these brackets 1.5 inches off of the floor so that I can maintain an air gap between the floor and my risers. Due to breaking my laser tripod, I'm filming this in a little bit of a reverse order. What I'm doing is I've mounted the outermost brackets with my laser, and I'm taking my level and then mounting the intermediate brackets up to my level instead of using the laser line for every bracket installation. I'm going to bring you in closer and show you the close-up of how I'm using the level to do this, and that I'm actually using a little bit of a spacer due to my block not being perfectly in plane, but once my system was nailed down, it went pretty quickly. All right, let's run through a couple bracket installs here using the level. So first thing I do is I position my level at the back of my brackets, and I'll use my spacer. You may not need a spacer. My substrate here is CMU block, so it's not perfectly flat, and if I were to simply mount my brackets back against the substrate of the block, because the block is uneven, I could get an angle to my brackets that I wouldn't be able to adjust, as well as this is an unfinished edge, and I don't want moisture absorbing out of the block into the plywood. So we're going to position our spacer position our bracket up against the level in the back, and we're only going to fasten the top screw at first. And what I'll do to be efficient is I'll kind of do 3 brackets at a time. So we're going to move our spacer over, slide our bracket up until we're making contact with the level, but you don't want to be exerting force on the level because you don't want to actually move the level. You just want it to be touching. Staging your brackets ahead of time with starting the screws will help make this go much faster for you. Alright, so after those are fastened, I'm going to pull my level forward to the front, and all of the brackets I've just installed are only secured with the top fastener. So I'm going to tap them downward. And what that's doing is making sure that they're not on an angle that is affecting our level. And I will now bring them up to our level so they're just barely making contact, and I'll fasten the final screw. You want to ensure when you fasten your brackets, there will be a little bit of movement, so just check and make sure that the movement was not enough that it's now way off of your line or pushing your level up or down. Because if one of your brackets does move your level, then all of the subsequent brackets you install will also be out of level then. And then you can kind of take your level and slide it back and forth here when you're done. And if all is done correctly, you can see how well this slides back and forth. I just wrapped up installing all the brackets. It's kind of late here now, but I'm too excited. I'm going to start loading it with lumber, and then I get to see how much space this opens up for me, because it already feels like a massive improvement. So I cannot wait to get this organized, get the lumber on here, and then clean up the other areas around the shop as well. This has been so long overdue. I cannot wait. I began with a quick vacuum up of the masonry dust from installation, and then it was on to loading the rack with my different materials. I designed this rack to be so large so that I can actually have a shelf for all the different commonly stocked materials I have on hand, and that center shelf is actually long enough that I can accommodate 16-foot material storage if I ever need to. Although most of my material is not that long, the left side is actually smaller, so it's what I call my selectaboard area, which is the area my sawmill has when I go there, with some smaller boards in it, typically under 3 feet, and it all fits perfectly over there. I'm very excited about this. If you made it this far in the video, I can't thank you enough. My shop really needed this, and if your shop needs it as well, head over to calculatedcarpenter.com, where I have the blueprint as well as the machine files I've used to build this available. I also have other files for CNC routers, lasers, and 3D printers, all machines I use in my maker business, and I think my next video might be fixing my CNC router. So until next time, keep making.